Earlier this year, we talked about domains, ranges, functions. So the first part of this lesson is going to be a mostly review. Recall that a relation is a set of ordered pairs. The domain of a relation is a set of all first coordinates, in other words, the x-coordinates from the ordered pairs, and the range is the set of all second coordinates, in other words, the y-coordinates from the ordered pairs. A function is a relation in which each element of the domain is paired with exactly one element of the range. So recall that there are actually several different ways to describe a relation. We can describe a relation as ordered pairs. So in this example, we're going to state the domain and range of each relation, then determine whether the relation is a function. And then it says if it is a function, determine if it is one-to-one, onto, both, or neither. So this is from your textbook. We are actually not going to do one-to-one, onto, or neither. So we are simply going to delete that portion of it. So don't worry about on one-to-one, onto, both, or neither. That's not mentioned in the book after this lesson, so we're not going to worry about it. So we have a table. We have the ordered pairs. These are the ordered pairs right here. And you can also write that as a table. So the way you would write ordered pairs as a table, that's what we typically call a T-chart. So you got the x's on one side, you got the y's on the other side. And all my unique x values are -6, and it goes with -1. So it's like writing the ordered pairs on the opposite sides of that line. So then we have -5, -9, -3, -7, -1, and +7, and then 6, -9. So that's what a table is. And then we have a mapping, and a mapping is when you have your two ovals, and you have your x oval and your y oval. And we write the unique x values. So the unique x values are -6, -5, -3, -1, and 6. And then we have our unique y values, which are -1, -9, -7, +7, and then there's another -9 over here, but I'm not going to write that twice. I'm going to write just the unique y values. And then we connect the corresponding from the elements from the ordered pairs. So -6 is attached to -1. We have -5 with -9, -3 with -7, -1 with +7, and then notice we have 6. We'll draw a line up to -9 like that. So that is a mapping. And then a graph, of course, is when you put them on a coordinate plane. So we can graph all those coordinates on a coordinate plane. So we have -6, -1, which is located here. -5, -9 is down here. -3, -7 is right here. -1, +7, that's way up here. And then finally 6, -9, which is down here. Okay, and that's by a graph. So then it also says to state the domain and the range and determine if the relation is a function. So the domain would be all of the unique x values, and that would be -6, -5, -3, -1, and 6. So you would just write the domain like that with these little funny brackets. And then the range would be the unique y values, and that's -1, -9, -7, and +7. Notice again, I do not write the -7 twice, just like I don't do it in a mapping. So that's the range. And then it finally asks, is this a function? So the definition of a function, remember, is a function is a relation in which each element of the domain is paired with exactly one element of the range. So every x is paired with exactly one element of the y. So if I go down here, that is often easily seen looking at the mapping. So notice that every x value is paired with only one of the y values. So the -6 is paired with only the -1, the -5 is paired with only the -9, the -3 is only paired with the -7, the -1 is only paired with the +7, and the 6 is only paired with the 9. So this is a function. Yes, this is a function. There is nothing that says that a y cannot be paired with two different x's. So yes, I know that the -9 has been paired back with the -5 in the x column and the 6 in the y column. However, that's not the definition of a function. The function is that each x is paired with exactly one y value, not every y value is paired with exactly one x value. Another way to see a function is called the vertical line test. I'm going to skip a little bit here. I'm going to go down here to the vertical line test. It says if no vertical line intersects a graph in more than one point, then the graph represents a function. So that's what this says right here. If no vertical line intersects a graph in more than one point, then the graph represents a function. So notice that on this curve right here that we're talking about, that if you take a straight line, a vertical line, and scrape it across the graph, so it might be your pencil, it might be a stylus, it might be the edge of a ruler. If you scrape it across the graph and you do not touch it in more than one place or at one time, then it is a function. If it does touch more than one place at one time, so over here, if a vertical line intersects a graph in two or more points, then the graph does not represent a function. So you can see how this line right here touches the graph in two different places because it touches the graph right here and here. So that means it is not a function, not a function. So if I go back up to here, up to my graph at this point, looking at those 5 points, does it represent a function? So can I draw a straight line, a straight vertical line, and touch 2 points at the same time? So the answer to that is no. I mean, you can try as much as you want. You can draw as many vertical lines as you want, but you will never touch 2 points at the same time. So I could draw a vertical line right here, but I don't touch 2 points at the same time. I could draw a vertical line right here, but I do not touch 2 points at the same time. So it is a function. Now, if I did have a sixth point in here, so let's say, for example, I threw in a point right here. Okay, so clearly if I threw a point in right there, then I could touch 2 points at the same time. So that would mean it is not a function. Not a function if I had that point in there. And the reason it's not a function is because what are the values, what are the 2 points? What are the coordinates of the 2 points? So this is at -6, +4, and then this one down here is at -6, +1. So notice that the -6 has been paired with 2 different y values. The -6 gets paired with a 4, and also the -6 gets paired with a 1. That's what happens when you have 2 points that are vertical. They have the same x value but different y values, and that violates the definition of a function. Each x value can be paired with exactly one y value. So now that we know what a function is, we can talk about discrete and continuous functions. So a couple new definitions. Discrete and continuous functions, a relation which a domain consists of a set of individual elements and the graph is a set of unconnected points, is said to be a discrete function or a discrete relation. When a domain of a graph has an infinite number of elements and the relation can be graphed with a line or smooth curve, then the graph is a continuous relation. So look at graph A. Graph A is just a bunch of unconnected points. All those points are not touching each other, so we would say it's discrete. And graph B is, notice that the graph is a straight line, and since the graph is a straight line, we would say that it is a continuous relation. And both of these are functions, even though it says relation, they are both functions because they do pass the vertical line test.